All right, the case study that I'd like to present to you today is a little bit different. It's not based on a project. It's based on the changes required within our business, D&E Air Conditioning, to implement BIM. The implementation of BIM, particularly the I, is far from complete, but we are drawing in 3D and manufacturing pipe, duct and prefabricated modules from these 3D models. Now, change that slide there. Before we started any implementation of BIM, we solely used AutoCAD to produce our shop drawings. We had 25 draftsmen and women, all with high-level CAD and drafting skills, and a limited number, approximately 2 or 3, who had done basic course in BIM software. Our hardware was just coping with 2D software and was not up to the standard for 3D modelling. Our network and server was still part of the then Hasty Group infrastructure and required demerging and upgrading. We were producing approximately 20 drawings a week for duct manufacture alone and had also completed prefabricated plant rooms using 2D traditional drafting processes. From 2D only capabilities, we now have 26 seats of Revit Premium Suite, 4 Ultimate Suites, enabling any 3D modelling or BIM project we wish to tackle. Hardware has been upgraded to over 17 high-speed machines with 24 or 32 gigabytes of RAM and one with 64 gig of RAM. The network infrastructure has been completely reworked, including a wide area network across 3 office locations. Servers in each location are running Hyper-V with multiple virtual servers, allowing Revit server and file management systems to run alongside other server functions. The main server is expandable in both processing power and storage capacity by simply plugging in extra modules. We now have 5 engineers designing in Revit and passing on the model for development and coordination to 12 full-time Revit drafters producing shop drawings for manufacture of pipe, duct and equipment. We have also developed processes that I'll show you later to allow us to train and expand our Revit resources quickly and easily. Before starting our implementation program, we considered what software to use and what would provide the best long-term match for our business and the industry going forward. This is no way a sales pitch for anyone's product. However, we settled on Autodesk Revit for several reasons, but mainly for us because we already had 25 seats of the basic product. It incorporated design functions that would decrease or eliminate manual design processes. It has the option for us to complete heat loads and energy modelling calculations as required. It has a strong interoperability with our existing energy modelling software, IES Virtual Environment. We had some staff trained in its use some time ago, and it's the predominant platform used by architects and consultants in the local industry. These are some of the reasons why we made the decision we did. Other companies will have different reasons for settling on the software they have chosen. I'm not suggesting it's the only way to go, but it is the road we've chosen and it's the road that we are now travelling. Like most companies, we had to have an incentive to spend the money and to make the change to BIM. So our true Revit implementation program started for a particular project. We had used Revit previously for parts of other projects. However, this wasn't based on a holistic approach, including all trades, the architect and consultants. At this stage, we didn't know if Revit could do what we wanted it to do, or even what it was that we wanted to do for us. So we asked, can we use it straight out of the box? The simple answer to that is yes. However, for models with meaning, customised families are required for equipment. For manufacturing, time needs to be spent creating ductwork families to represent those standard fittings made in the factory. This is the piece of the puzzle that we hope that BIM Oz will complete for us, allowing out-of-the-box Revit product to be used to create models that include real equipment and materials to a common standard. At this stage, we have not used BIM Oz as it has some development work still to go. However, our duct and equipment families have been made with BIM Oz philosophies in mind. We also asked, what can it do? Interestingly, we continually heard that it can do whatever you want it to do. This is not entirely true. There are some limitations, and the software does not always do what you want, and more specifically, in the way that you want it to do it. Revit can do a lot of things and do them well, and can be customised to do much more. But it is this customisation that takes all the time and planning. So it is important to remember when working through the implementation process to keep it simple. We attempted some significant customisation, however rolled this back as we discovered the benefits didn't justify the effort. We knew the proper implementation process would mean detailed analysis of how we currently do things, and possibly these processes need to be modified to suit the software. So first we had to figure out what it was we actually do to produce a drawing, which involved both engineering and drafting processes. To do this, we mapped out these processes. We started, as per this diagram here, at a high level, outlining the main blocks of the overall process. Then we drilled down to the detail, including all the steps in the process, along with possible options or choices that are available at each step so that the workflow covered the widest range of projects possible. The actual workflows shown here are a workflow for the Revit setup, so how we set up our models, how we make the decisions at the beginning of the project. The concept design, including a subsection there in the red for heat loads, which is nothing to do with the Revit software, but a relevant part of the process. You'll notice that some of the blocks here are different colours. This is not coincidence, it's intentional. The yellow blocks here are engineering tasks, and the white blocks are the drafting tasks, but you'll notice that they all link in together. We also used standard flowchart symbols. So for example, diamonds shown on the flowchart represent a decision to be made in the process, and the wave blocks represent documents for both input and output from the process. This is our process for detailed design. So IP has been mentioned a lot with BIM and as a regular topic throughout this forum. And we believe that the real IP in BIM is in workflow maps like these, and not the model or the data that they contain. The value for your business comes from what you do with the model and what you do with the data, not the model and the data alone themselves. So following through, that's our manufacturing workflow process and a coordination workflow process. After mapping these processes, we knew how we did things, and we could look at what we needed to change in order to use the software to its best potential without sacrificing important parts of our process. It is also important to note that as we learned how the workflow interacted with other contractors, we made some changes and improved some parts of it. To control the detailed processes and the documents they require and produce, we decided to implement another software package as well. This was not a drawing package, but a document and workflow management package called Vault that would control versions internally for us, revisions externally, and control document workflow milestones, access to documents, as well as allowing users to search and find only the latest revision of what they needed. Following the process planning, we needed to learn how a project model was put together. Our research told us that size of the model and file sizes was important to the speed and operation of our productivity. We had to learn how to break up a model into separate model files and how this would affect the workflows that we'd produced. So this slide shows simplistically the model breakup for the project that we're doing our implementation on. And for the project, we started with 24 models in the breakup, but it will end up being more than double this number. Managing this number of models becomes a challenge, and we considered federating these models to help. The models vary between 40 and 130 megabytes each, making a combined federated model over 1 gigabyte in total, so without any information added to any objects. So no data, just the model itself. So this was too large, we found out, to run on the fastest desktop machine that we had, even with 64 gig of RAM. So we avoided the need to federate these models in our processes. We've incorporated work sets in the models to further assist in controlling the computing resources that we needed. The Revit files and their functionality were not suitable for filing in Vault, so a common location on a local server was found to store all the central model files. The central model files were used for all users to synchronise to provide a central storage point for all modelling work. Revit server was set up to enable multi-location input to models. However, workload at this stage hasn't required resources to be used across multi-locations. Revit server also provides the challenge of linked file updates that occur at least once a week. The upload and sync time was too intense for it to be practical to make weekly uploads. As mentioned before, customisation is important but needs to be limited. We've resisted spending extensive time building libraries of families to cover many different equipment options. Instead, we've tried to obtain families from suppliers, if possible, and create only those essential for duct pipe and equipment to be documented correctly. Again, we're waiting for BIM Upgrades and suppliers to further fill this gap for us. We've created duct families that represent manufacturable components and are working through with Autodesk on some nuances found in their functionality. In no way are our duct families complete, and we're continually finding shapes that need to be created as families. Being novices from the start, we enlisted then CarolCAD, now A2K's expert help to guide us through our implementation program. They assisted with a program plan, training, technical support, configuration setups, and health checks both on us and the models. It is a long road, and we still have a long way to travel. However, from our experience, the road would have been a lot more bumpy if we didn't enlist expert assistance. We now have the momentum and the documentation to carry on alone with our Revit implementation work. However, there will always be part of BIM implementation that requires greater minds than ourselves to complete. So considering all that we've done, as marked on the BIM Upgrades execution plan here, what is left to complete on our road to BIM? We need to create more detailed duct families. We need to integrate a finished BIM Upgrades plan and supplier models into our processes. We need to work on round-tripping data to and from Revit for distribution to our suppliers. We need to format our schedule outputs for population to represent data from the model in a useful format. We need to accelerate our manufacturing detailing and improve our tagging efficiencies. And we need to take equipment data to commissioning tablets. What is required will be different for every company, as each will have different expectations of what BIM can deliver for them. In hindsight, what would we have done differently on our road to BIM so far? Would we have chosen another software package? The simple answer there is no. Even though there are many things that need to be developed in the software to allow us to do what we want, the way we want, we believe that the development intentions are heading in the right direction. Looking back, one thing that we should have considered in more depth is the use of a Citrix system to allow us all our processing and storage of models to occur in a central location and remote screen portals used as the user interface. This would mean less outlay on hardware with new drafters starting and all locations could easily be enabled as Revit ready very quickly. Revit Server, even considering that it's a free piece of software, was not an ideal choice for enabling modelling across sites. Bandwidth between sites is essential with Revit Server. However, the maintenance and constant uploading of files make it labour intensive to maintain. Where do we want the industry to head, and more importantly, what is the right direction for us all to take? This is a question that we've heard a fair bit in the seminar so far. We've seen earlier from Rob's presentation as to where the software is headed, but where do we see the industry needing to head? We need to get past inhibitions and ensure that for the betterment of the project, and therefore everyone, that early design development discussions and documentation are not wasted, but passed on to the construction team for use in construction. Too often information is not passed forward in the construction process due to a lack of communication between the right parties, which hinders construction teams' ability to deliver the early design decisions. BIM and BIM processes definitely force the design and construction teams to be involved together earlier, but we need to ensure models move from design to constructible models with fabrication outcomes to gain the real value. Moving these processes earlier makes it easier to consider further efficiency improvements like on-site prefabrication. While prefabrication does not require 3D drafting or BIM to make it possible, it definitely makes it faster and easier. Thank you for listening, and I hope that you've taken away at least one useful point from what I've presented here today, and look forward to seeing more outcomes from BIM Upgrades. Thank you.